Hello, I'm Richard with EV4U Custom Conversions. Welcome to another episode featuring the 1966 Porsche 912. In this episode, we're going to take care of a few little things that need to be done while we're waiting on some parts. And so, first off, we're going to get the motor out of the box, put it on the workbench, and attach the adapter, coupler, flywheel, and clutch. So stay with us as we start progress on the 1966 Porsche 912. So here you have it. This is the motor that's going to go in that Porsche. It's the High Performance Electric Vehicle Systems AC51. It's a three-phase AC induction motor. And this is the box it came in. And it weighs about 128 pounds, I believe. And so I'm here by myself. And so I could probably lift it. But at my age, I've learned one thing, and that is don't try to show off anymore. It's not worth the consequences. So we're going to lift this onto the workbench with the help of a cherry picker, and then I don't have to worry about my back talking to me the next week or two. Okay, here we have the motor up off of the ground so you can see it a little better. If you notice on this end, it's all open so that air can flow in past the armature. And on this end, again, it's slotted. There's an internal fan in there. And so just like on the net gain motors that many of you are familiar with, it's drawing air through the motor to help cool itself. These inherently run cooler than the series wound DC motors, such as the net gains, because they don't have a commutator. They don't have that area of resistance that creates heat. So they naturally run cooler. And so High Performance Electric Vehicle Systems makes these sealed, and they make them vented. And so for our application, it's nice to have the additional cooling capacity. But if you were, in a mining operation or something like that, or we've done these for off-road applications, then you want that sealed so you don't get dust in there and dirt and so forth. So let's move this over to the workbench, and we'll take a little closer look at it, and we will mount our adapter plate to it. You know what? Let's take a little closer look at it while we have it floating in the air here, at least part of it. Here's the drive end of it, and see if we can get in a little closer. So you can see on the drive end here, we have a key slot. You can see the bearing in here. You can see the fan blade in there at an angle. Don't know if I can get the right angle for your camera. But anyway, and then on the opposite side here, and I have this just tucked up out of the way. Here's the wiring for it. So here we are sitting on the workbench. I just wanted to show you a little closer up view of this. Like I said, I just have this stuck here out of the way so it doesn't get caught on anything. but these are our 3 phases in. And so, like I said, they're marked U, V, and W. And that will correspond to the markings on the controller. So we showed you the connections on the motor. We'll just show you the controller real quick. This is the Curtis 1239-8501. You can see here the markings on the controller. You got W, V, and U. And then on this side we've got, this is basically come from your battery pack. And so you've got your negative and your positive. Now we'll show you when we get to that part of the project that it's not coming directly from the battery pack, it's going through a contactor first, so forth. And we'll show you all of that. So just wanted to show you the corresponding markings here, how very simple it is. Just a couple other comments on the motor. I mean, I don't know if you can tell the scale just by looking at it or not, but this is really a very small package. This is basically just under 9 inches across, so our diameter, and then it's just 14 inches long, not counting the shaft here. So nice small little package. So this small package will put out, and this is with that controller I showed you, 500 amp controller, running at a nominal voltage of 146 volts. Things will be putting out 88 horsepower and 100 foot-pounds of torque, a maximum of 108 foot-pounds of torque, and maximum horsepower of just over 88. So not too bad for such a small package. So now let's move on to the adapter coupler. So let me show you the adapter. This is the adapter. This is the side here. You can see that mimics the back end of the case on the Porsche 912 engine. And so this is the side that mounts to the bell housing. And then this side mounts to the motor. And so it will mount just like this, and there's a marking for top here. Line up our bolt holes. We'll use Loctite on these. I'm just putting it in so it doesn't fall off while I'm talking. So that's what that'll look like. So let me grab the coupler and show you what that looks like. Here's the coupler. These are off-the-shelf components. We didn't make these, we purchased these off the shelf. This one is from Canadian Electric Vehicles. And this is the mounting pattern for the Porsche 911 flywheel. We're running a lightened Porsche 911 flywheel on this. And then this is the side that'll mount to the motor. And this will seat on the shaft here. There's a little ridge. This will seat all the way down to that. And then there's a couple of set screws to set on these. And it uses a key. There's a keyway on the shaft I showed you before. And there's a keyway here. Now, the company that sent the coupler and this and the adapter, They didn't send a key, but luckily we have a bin full of them, so we got that covered. Here is the light and flywheel. This is from Pelican Parts. They're one that carries a lot of Porsche parts. So this is the light and flywheel. You can see it's been drilled and machined a little bit so that it's lighter than stock. We could go lighter yet if you machined off the starter gear on this, but we don't go through that trouble. So anyway, this will be the flywheel that will go on there, which will mount here. So what we're going to do first is we're going to mount the coupler onto the shaft here. We'll need to install our key. But most of these that I've done, they're a slip fit, and this one just won't quite go on. I mean, I could probably talk to it, get it to go on, but instead, I'm going to heat this up. And so we'll heat this up, and then it should just slide right on. So that's what's up next. So here I am warming up that coupler a little bit, just using a heat gun. It's just a little bit snug, so it doesn't require a lot of heat or expansion here. But when I put it on, it'll just fall right on now instead of having to really work at it. So I just kind of a few seconds every 90 degrees on this thing to heat it up, and that should be sufficient. And so now I'm just going to line it up with the key. There, you heard it hit. It's all the way in. So now I'm going to let it cool, and then I'll tighten up those Allen screws, set screws, and Loctite them, and that portion will be good. And then we'll move on to the putting the adapter on. So we'll give her a little time to cool. And all right. While we're waiting for this coupler to cool down, you can see I can touch it. But we're going to let it cool down a little bit. And so in the interim, I want to show you something else that we start fairly early in the game, just because it's time consuming. And if we're doing it all along, then it's really not a big deal. It basically does it by itself. It's not a lot of our time, it's just a lot of time. And what that is we're going to bottom balance our pack. Now I'm not going to go into great detail on that. We've made a video in the past talking about bottom balancing, why and exactly how we do it. So this is just going to be kind of a very brief overview. At this location, I have a Cell Pro Power Lab 8 that we happen to have for use here. And because my office is on the other side of this wall, it's handy because I don't have to be here to babysit it. If I go out to a meeting or whatever and come back, it doesn't matter, because this is going to do its job and shut off with or without me. And so what we do is we'll take one of the cells, we do them one at a time. This is a pack of 44 sitting right here to my right. and we're going to bottom balance these one at a time. The goal is to have each one of these cells read 2.75, 2.76 volts. Different ones seem to just come in at one or the other of those readings. Some we do at 2.75, some just seem to all kind of want to be at rest at 2.76. So we'll see how this comes out. But we always take a starting reading, just so we kind of have an idea of where everybody's standing. In this one, this will be our first one we're doing. I'm going to write down what I measured. It's 3.31. And so that's kind of the starting point where we got it. That's the voltage. But that is not truly indicative of the capacity or of the state of charge. According to the sheet that came with these, most of them have a capacity of 116 amp hours. These are our 100 amp per hour rated cell. And out of the, well, this is probably one of the better ones I've seen. Most of them are 116 amp hours. There are two that are 117, and there's one at 115. And I can figure that out because they give you serial number, barcode, they give you the internal resistance, open circuit voltage, and the capacity. So we got the specs on this pack, and I can see exactly which one is which. I really don't care. Bottom line is, this pack of 144 cells has a maximum capacity of 115 amp hours. Your pack is never better than the least of the cells. Kind of like the chain, weakest link. But what we're going to do is we're going to bottom balance these so that these all start off at a common minimum reference point. And then once we've established all of these at that 2.75 volts, they'll be installed in the vehicle, wired in series, and charged together as a pack, which means that they will all have the same amount of energy going into them, and as the vehicle's operated, they'll have the same amount of energy taken out of them. We have packs that have been on the road since 2008, and those that have that we've had the opportunity to come across and take a look at them, and it's just great to have that opportunity and to see. They've all been dead on. The pack out of the Bug was inspected not too long ago, dead on. The Karmann Ghia, which gets the most mileage put on it, it's driven every day, an average of 50 miles. We've driven it over 80 miles. I think the most we've driven it in one day was 86 miles. But that car is just, you know, it's driven quite a bit. And those cells are all dead on. And how do we know that? Well, what we'll do is we'll drive the thing and we'll bring it down low, lower than we do any other time. We typically, I don't think that car's ever exceeded 76 or 77 amp hours, and that's rare. Typically it's in the 60 to 70 will be the maximum that we ever discharge at. It does a lot of short runs, 25 to 35 mile round trips, and it's back in the shop and it's plugged in. There are times where it'll do 45 miles in one outing, and occasionally 60 or a little more than that. And on those outings, I'm driving conservatively, and and still have not exceeded the 80 amp hours available to us in that pack. Again, that pack is the same as what we're putting in this Porsche. It's 44 of the Calb CA series 100 ampere hour cells. And so what we do is we'll run that pack down on purpose, real low, get these cells down below 3 volts, and then take a reading and see if, you know, if there's any variation in the cells. And we have yet to find any. So we are very comfortable and confident in these cells and in their ability to stay where we put them, so to speak. Once they're balanced, maintaining that balance has not been an issue. So anyway, how this Cell Pro Power Lab works, they make different ones. This is the Power Lab 8. This actually has the capability of discharging at a 40 amp rate. We always set it at 30 amps. And the reason for that is the wires that they provide are a little light. And at 30 amps, they get hot enough that you can't hold on to it. And so at 40 amps, I'm sure that that's pushing things. So we're not in that big a hurry. It's doing this on its time. We've got other things to do. This vehicle will be in the shop with other work being done while these are doing their little routine. So the Power Lab runs off of 12 volts. And so you can hook it to a power supply, whatever. We just happen to have an old AGM battery that we use for different things in the shop here. And so I clip onto it. Now, what I have it programmed to do is to discharge at 30 amps down to 2.5 volts. And it's going to be taking the energy out of our cell that we're bottom balancing and putting it into this one. Well, I can only put so much into this, and this would no longer be able to do it at the 30 amp rate. So we have a headlamp that we have sitting right there that we'll plug into, and that will drain down this battery to maintain a level. There's just enough current draw off of that. It's slightly, it's just slightly more than 30 amps. If we leave that on continuously, it will draw this down to where this would shut off. So we don't run that continuously. Just when we notice that this is starting to cut back, then we'll put this on to maintain that constant 30 amp draw. Hope that made sense to you. So anyway, these are very simple. You know, it gets its power from, you know, needs 12 volts to operate. And then we connect these jacks. They got a fuse on each line. It's the way they come. They're 40 amp fuses. And we connect it to our cell that we're bottom balancing. Now, they come with different leads available. I don't know where I set the ones that were plugging this. Anyway, we've got different ones of these, different leads that we use. These are set up for these cells. It's just a ring connector, and then the bolt and some washers. We use these versus using the alligator clips because the alligator clips don't seem to be real consistent as far as a connection goes. So by using these, we get a good connection every time. I can pretty much tell you, you know, if we time how long, and this does it internally with the Cell Pro. It'll tell me how long it takes to discharge this. I can tell you all the others are going to be, you know, extremely close to that. And because they come, well, typically there will be about, let's see, if they take a couple hours usually to discharge. So there's probably, you know, 60 amp hours in these when received. Sometimes a little less than some that we get in, but most of them are in the hour and a half to 2 hour initial discharge time. And what I'm going to do is we're going to do one, and then we'll talk about the rest of the process. This isn't a single stage process. In other words, we're going to discharge this down to 2.5. Once the load is removed, this is going to bounce back up to typically a 2.88 to 2.91, somewhere in that range. And that's higher than our 2.75 target. And so we're going to have to do it again. So what we do is we'll discharge them, and we give them a chance to rest, at least, you know, overnight, the minimum. We typically, because we're running through a pack, we'll do like 11 of them at a time, kind of thing. And so they get plenty of time between the discharges. So then, once we do that initial discharge, and we put a little dot, we use a little permanent marker, we put a little dot here to remind us where we are. And so when this one is finished and it's sat, we'll take another voltage reading, we write that down, and I'll know exactly where this bounced back to. And then we'll discharge it to 2.65 volts the second time. And of course that will go much quicker. That doesn't take very long the second time. Matter of fact, you typically are working on the workbench because it will be doing that within minutes. And then, you know, we cycle through that group of like 11, so they have plenty of time. We want to give them, you know, like an hour's time to bounce back, 30 minutes minimum. And again, when it bounces back, we'll take another reading. The second time, it's usually in the 2.79 to 2.81 range is typical. And then the third time we'll do it to 2.7 volts, and bang, it should bounce back to 2.5 or 2.75 or 2.76. At that point, we let it rest again. You know, we'll record that reading. We make a mark each time. So at that point, we'll have 3 marks. And then after we go through the whole pack, we'll come back a 4th time and just do a little tune-up to make sure that they're all exactly the same. 2.75, 2.76, whatever it may be. That 4th time, we just kind of do that extra little dial in. Not really necessary probably, but that's just kind of the habit that we have. And so when all is said and done, we've got a battery pack that have all the cells at the same minimum voltage. And then they're ready to install in the pack. And when we get to that point in the process, we'll share that with you. So right now, what I'm going to do is start this up. So it's some people have confusions about this. Let me show you. We'll zoom in and take a look at the settings on this. Okay, so you can see what it's set at. It's just the selection in here that best matches what we're using. LiPo generic, set at 30 amps. We're not balancing multiple cells here. But you can see, you know, it's got lots of different choices that we can walk through and do. from lead acid, NiCad, so forth, and you can program different ones in. So you can see lots of different choices. So I'm going to press both these buttons, increase and decrease. This takes me to the options. It says press both buttons for options, no secret here. And it says choose task. And so I can go into the preset settings here, and you can set increments. You can set the charge rate, and again, you can adjust it. We're going to run it at 30 amps. Doesn't matter, we're not charging anyway, but we just leave it at that because we never charge more than that. Cell level, if you were charging it, 3.5. Beeps. Bunch of stuff we're not really, cold weather set point. The shop never gets down to 41 degrees. Set discharge rate. That's the one we're interested in right now. We're set at 30 amps. And this is the other one that we're interested in. This one we will change. 30 amps, we're going to continue that same discharge rate throughout our entire 4-step process. But this will change. So we're going to, the first time we're going to do 2.5. Then we do 2.6, sometimes 2.65. We'll see how they bounce back and everything. We get a feel, for the batch that we're working with. And so this is something that we adjust, again, using the buttons over here. No cycling, and so forth. So now to get out of this menu, we're going to hit these two buttons. And it takes us back to our starting point. Okay? So now what I'm going to do is I'm going to hit enter. No parallel packs. Don't care about that. That's correct. Start charge only, no. We're going to select here, monitor, no. Regen discharge only. That's when it's going to take out of our cell we're balancing and put it into the 12-volt battery that's doing, that's providing the power for our power lab here. So yes on that. Use banana jacks. That's these jacks right here. There are other jacks that the RC world uses and everything. Don't care about that. And it says checking pack. It's checked it. Everything's good. Hit enter. And so now it's doing a regen discharge. One cell, 30 amps. It's going to take it down to 2.5 volts. Okay? Now, in a moment here, you're going to hear a fan come on because it's discharging, and it's, we're pulling 30 amps out of this cell, and so it's going to get warm. And so it will then, turn on a fan to cool itself. That's it, folks. Not too complicated. Pretty cut and dry. So, meanwhile, back at our motor, this is nice and cool now. It's not quite as cool as the end here sitting, but it feels body temperature. So now I'll put these set screws back in with some Loctite. Don't need to waste your time watching that. And then we'll install the adapter. All right, folks. That's one coupler installed. Now for our adapter plate. Again, all this does is allow us to mate this motor to the transmission in the vehicle. The critical part in all of this is that when this is all together, and our flywheel's on here, that we have the same distance from this mounting edge to the back edge of the flywheel as the original gasoline engine had. That's what we're replicating. So let me find the top here. There we go. Now I'm going to install these without Loctite this time. Because we're going to be taking this off, and I'll show you why later in the game. But for now, we're just going to put this snug because we're going to use this for two things. One is, once we have the flywheel installed, we're going to check and make sure that that distance I just talked about is correct. That's what some people refer to as the magic number. And so we want to make sure that that's correct. We didn't make this adapter or the coupler, so that much more reason to double check it. We double check our own work. We definitely double check other people's work. So anyway, that's one reason why I'm doing this at this point. Why I'm not Loctite will become evident later on, and I'll share that with you when we get to it. Anyway, the other reason I'm putting this together right now is I want to be able to design our rear mounting on this. On your Volkswagens, your air-cooled Volkswagens, one of the very few vehicles that doesn't have any additional motor mounts. You would mount this to the transaxle, you're done. But in the Porsche, there's a rear motor mount. And we did a video that just shows the rear motor mount setup for a Volkswagen Transporter, a 1991 Volkswagen Transporter. Just because people were interested in that, and so it was actually part of another video that we segmented out and made a separate video. So anyway, we're going to mount this in the vehicle. It'll be supported by a jack, and then we will do our alignment and take our readings and design our rear motor mount. Now, because we've done this a few times in the past, we know the basic design. What we're doing is, getting the exact measurements for this vehicle so that everything is dialed in exactly where we want it. So once this is on, then that's when the flywheel comes in. And so the distance I'm talking about is from this mating surface between the bell housing and our adapter and the flywheel right here, this surface of the flywheel. That's what I want to know. What's the stock measurement, off the stock gasoline engine? And I want to make sure that this matches it. Okay? So I'll mount the flywheel. It takes a second because these are not all evenly spaced. So it's not symmetrical. And so you got to kind of rotate it and get it dialed in. not going to waste video time on that. So there you have it. That's the adapter coupler mounted on our AC 51 motor. We have our 100 ampere hour cal cell here being discharged at a rate of 30 amps. The screw head is hot. I mean, if it was any hotter, matter of fact, it's almost too hot to just lay my hand on there now. And so, like I said, see, I can't even touch that wire with 30 amps going through it. So that's why we don't run it at 40. We could make new leads for it, I guess, but we just run it a little slower. We're not that big a hurry for that part of the process. We've got a lot of other things to do while this is doing its job, and it's doing it while I'm making a video. See, can't get too much easier than that. So here it is, motor with the adapter, coupler, flywheel, and clutch installed. So now we're able to take this over to the vehicle, mount it to the transaxle. Supporting it with a jack, we will be able to determine our measurements for our rear engine mount. And I'm going to show you that later on. Well, let me show you where we mount it to on this. I'm going to have to pull it off the workbench to show you that. So let me hook it up with the cherry picker, pull it off, and we'll let you take a look at that. All right, we've picked the motor up off of the workbench. It's suspended here by the cherry picker. So we're going to lower it down onto our transmission jack, and we'll take a look at that in a minute. I have mentioned in previous videos the reason I like the transmission jack for installing these electric motors is that it adapts to our cradle, and we use the same cradle on the workbench as we use on the jack, and it allows us to make multiple adjustments. We can raise and lower, we can tilt, and we can rotate. We can tilt, you know, both directions, X and Y. And so, very nice tool, much better than a floor jack for installing one of these. Now, what I was talking about and what we're going to need for our rear motor mount are these 4 holes on the back here. Now, I'm in one of them right here with the eyelet here, lifting eye, but they're 90 degrees apart. Here's another one, there's another one, there's another one. And so, actually the way this is hanging right now, it's hanging 90 degrees off. This is top right here. This will be the top of our motor. And so when it's in the vehicle, this will be vertical right here. So this will be rotated 90 degrees. So this won't be quite on top, but this flat spot is. And we'll show you how that goes. And we'll show you where we're going to locate the controller and that type of thing. But for right now, what we're going to do is we'll lower this down onto our transmission jack. And that would be where we're going to call this one quits. So you can see the transmission jack right there. You can see the cradle. And you can see we're just coming down nice and slow. And we're going to catch this thing on the cradle. Then I just simply have to rotate it 90 degrees. and it's ready for installation on the vehicle. But that'll be another episode, and there's a reason for that, is the customer hasn't sent us the rear motor mount. We don't have that yet. We've been waiting for it. So once we have that, we can move forward. So anyway, you can see how nicely that sets things up. And we're ready to rock and roll then. One thing about the net gain motors is they have a hole, a threaded spot for a lifting eye here, and it's balanced with just the motor, so that's nice, but it's no big deal to accommodate this. And like I said, we're just going to rotate this now. It's only 128 pounds, it's not a big deal, plus the weight of the flywheel and clutch now, but adapter, but not bad. So here it rests, ready to go in the engine bay. And like I said, I can raise and lower it, I can tilt it front to rear, and I can tilt it this way, which basically is just allows for rotation, so that we can get those bolt holes aligned just perfectly. Makes for a real nice installation method. Now, there are those vehicles where you have to go from above and we have to strap them and use a strap and go in from above. But on the Volkswagen and Porsches, this works really nice. And be surprised, it works real nice on a lot of other vehicles. There's been a lot of times we use this method, but we'll drop the motor in from above, drop it back down onto our transmission jack, and install it from below. Well, as always, I hope you enjoyed the video. This is just the beginning of this project, featuring this 1966 Porsche 912. So we're just barely getting started. Once that rear mount comes in, we can design how we attach it, or how we attach the motor to it and everything. That rear mount will serve a couple purposes. One is it supports the weight of the motor, but it also keeps it from rotating. In other words, it secures it from torsional rotation, from torque rotation. And so, an important piece of the picture, and it's a custom piece to all this. The clutch and flywheel, the adapter, coupler, motor, the controller, battery cells we looked at, all those are off-the-shelf components. And so, very easy, anybody can order a part. But this part will be a custom piece that we'll make in-house, and we'll give you some insights to that so that you could have some ideas on how you could do your own. And speaking of doing your own, that's why we do these videos, to help you have the insights and confidence to do it yourself. But what I really recommend, because these videos are not in depth, just don't have the time. This video has taken me all day. I mean, I've had so many interruptions. It just takes forever to do one of these. So your best option, if you really want to learn how to do this yourself and understand the big picture, understand component selection, how it all goes together, is to attend one of our 3-day hands-on conversion workshops. We have 3 on the books left for this year. We have one coming up next month in June, one in July, and one in August. And that's all we have scheduled, or have openings for, I should say. After that, we don't have any even scheduled for 2016. And based on how busy we are all the time, it's getting hard to do those too. So, I mean, here I am on the weekend, so I could try to squeeze in time for a video, and almost didn't make that. So anyway, hope you appreciate it. And as always, if you have any questions, don't post a question on YouTube, because we probably won't answer it. If you want an answer to any questions or comments, address them to info@evforyounow.com, and we'd be glad to answer your concerns and questions. And until next time, we hope that you will consider doing your own electric conversion.